Next best practice suggests that the instructions in the prompt should say what to do instead of what not to do. When instructions are phrased positively, the model is provided with clear guidance on the desired action, making it more likely to generate accurate and contextually appropriate responses. Research has shown that with this strategy, LLM performance and effectiveness improves by an order of magnitude. Here is an example of a badly written prompt wherein we are asking model not to forget to include references to sources it used to generate the response. Here is the positive version of the prompt in which we are asking the model to include the sources it used for generating the response. The next best practice suggests to instruct the model to play a human persona role. This is to guide the model to generate a response that will be close to the response produced by a human playing that role. For example, if we feed this prompt to a model, explain the concept of AI models, the response will be very open. It may be complex or it may be too simple to be of much use. So a better way would be to think about the consumer of the response and then instruct the model to play a role suitable for that consumer. For example, let's say the consumer of the response are middle schoolers. In that case, we will suggest the model to play the role of 7th grade science teacher. If the consumer of the response are graduate students who have background in computers, then we can ask the model to play the role of a college level computer science professor. This way, the response will be generated by the model, keeping in mind the suitability for the intended audience. If we can provide the model with trusted information that is relevant to the current task such as question and answering, then we can instruct the model to use only the provided information to compose its responses. This way, we are not dependent on the model's parametric knowledge to respond to the query. At the same time, we can ask the model to say, I don't know, if they are unable to produce an answer from the provided information. As an example, think of a company that sells thousands of industrial products. Each product has a complex product documentation. To answer the customer's question on a specific product, the product documentation itself can be passed to the model as a source of information for answering the question. This works out great as it prevents hallucinations and imprecise responses. One thing to note here is that to use this practice, there should be a mechanism for fetching relevant information from the enterprise's knowledge base. And that is what embeddings and vector stores is all about. These topics are covered in later sections. Next practice suggests specifying the characteristics of the output. Some models by nature are chatty, that is, they may generate large output that may not be useful or even required. This has an impact on the application's effectiveness, performance, and cost in case of third-party models. You can guide the model to limit the size of the response, as I am showing in this example, wherein I'm asking the model to keep the word count for an essay to around 150 words. The response from the model will typically be used by an application component rather than by a human. In order to make it easier for application components to consume the output from the model, you can ask the model to generate the response in a machine-friendly format such as JSON, CSV, or XML. Here in this example, I'm asking the model to generate the response in a specific JSON model. Now a quick word of caution here. I've observed that some models that are not trained on programming code generate JSON that is not well formed, and that gives parsing errors at runtime. So this becomes another critical factor to consider when selecting a model. Next practice is suggested for addressing biased responses. Idea is to set the guardrails for the response to prevent generation of biased, disrespectful, and harmful content. The guidance can be provided in the instructions. Here in this example, I'm asking the model to play the role of customer service agent who is respectful, always tells the truth, and promotes fairness and positivity. Keep in mind that many commercially available models are trained to suppress generation of biased and harmful content, but there are many models that need to be guided. Test the specific model's behavior with multiple guardrail prompts to learn which one works out the best for the specific model. Append the guardrail text to all prompts, though this practice will increase the cost of the model usage, but at the same time, it will lower the risk of harmful content generation. Our focus in this lesson was on prompt engineering's general best practices. Let's go over all the practices that we have covered in this lesson. Prompt is made up of multiple parts. You need to clearly demarcate these parts by using separators such as tags and labels. Instructions guide the model to generate the response. These instructions should be detailed, clear, specific, and without any ambiguity. Models produce better results with positive prompts, meaning they work better if you tell them what to do instead of what not to do. Now, our ultimate goal with models is to make them behave like real-world personas. It is found that models are able to play roles played by humans. So ask the model to play a specific role, for example, as a fifth grade teacher or as a polite customer service agent. Models use parametric knowledge to answer questions, but models do not have knowledge specific to your enterprise. They may generate hallucinated and or imprecise responses. You can prevent it by furnishing the model with trusted and relevant information. You should provide clear instructions on response characteristics. Ask the model to limit the size and suggest format for the responses. In addition, instruct the model to be polite, respectful, and fair so that bias can be avoided. Happy learning, and I'll see you in the next class.